Oof. All right. Okay, like I said, my name is Cody, and oop, 1 second. You love Python. Oh, okay, so some of you guys know about Python already a little bit. Python is cool. Yes, cool, cool. Okay, I'm going to share my screen with you guys. One second. Okay. All right, so my name's Cody. We're going to be going over some of the basics of Python. These are the tools that you're going to use every day when you get into coding. Like I said, these are the basics. We're going to go over some of the simple math that Python can do for you, and then we're going to talk about words, which are called strings, and then some of the operations that you can do with them. We'll also go over loops, while loops, and what an if and else statement are. Okay, a little bit about me though first. My name is Cody. Like I said, I was in the military for 6 years. That's me on the left side in that picture. We are up in Norway there. I was a rescue swimmer in the Navy, so my job was to jump out of helicopters and swim and help people that were, in trouble. And that's what I did in the military for 6 years. And then I just recently got out about a year ago. Now I'm a student at Jacksonville University, and I study physics in hopes of one day becoming an astronaut. Okay. Let's get right into it. First things first, what is Python? Python is, like some of you guys already know, it's just a computer programming language. Just like any other language is a language, like French is a language, Spanish is a language, and that helps us talk to other people. Python allows us to talk to our computers, and it allows us to get the computer to do things for us. It can be used in science, math, and engineering. Like I said, I'm a physics person, so I use Python a lot to perform math operations that are a little too complex for me to, write out on a piece of paper or even calculate on a calculator. I can get Python to do these really crazy, complicated equations. And I'll show you an example. I use this. This is a code on another website called Trinket, and I coded this last year for my physics class. And it's loading here. This is called VPython. It's a visual of Python. You guys see the, yeah, there it goes. So this is our solar system. The middle is the sun, and then Mercury, Venus, Earth, and Mars on the outside. You can see how Python can be used for real life applications, right? Hopefully we're launching to Mars soon. We are actually launching the rover Perseverance soon to Mars, and they're going to use something like Python to code when Earth is closest to Mars in its rotation around the sun. So that's a real life application that we can use Python for. And like all this code, it's like crazy calculations, crazy big numbers. I had to calculate the force of gravity between the sun and Earth, and the sun and Mercury, all the other planets. Planets are very, very heavy. So those numbers are huge, and the distance between them are huge. And those are the numbers I had to use to calculate the force of gravity and to get Python to make the planets rotate around the sun. So I'm not going to do all those calculations myself, I'm just going to type it into Python, and it will do those calculations for me. And the things that I'm going to be teaching you now are the basics, but that's really all I did for this code, and it came out with this really cool result. All right, let's get into it. Python's like anything else. Sometimes it can be frustrating, but the more you do it, the more you learn, the better you get at it. It's just practice makes perfect. Just like when you do any sport or any activity, you know, you just practice it. Go back to the things that you didn't understand, practice those some more, and something will click and you'll just get really good and you can code some really, really cool things. Like today, I said we can use it for math and science, but it's also for other things, like video games. And video game writers use code, and like Python. And actually at the end of this session, we're going to do a little game ourselves. We're going to create a game called the number game, or guess the number game. So let's get started with math. So some of you guys said you already know Python a little bit, so you know to get an output in Python, you need to type the word print. Is everybody on repl.it? If you're not, you can go to, just type in repl.it in the search box. Okay, that's fine. I'll go back to this. So up here in the search box, just type in repl.it, and I'll just do it too. And follow me. Okay, so it'll take you to the home page here. Start coding, click that button in the middle. And Python, I don't know if it's the first one for everybody, but if it's not, just type in Python where it says language. And then click it, and then create REPL. And it should bring you to the coding page. All right, is everybody good? Everybody on the website? No? Okay, I'll put the link in. 1 second. Okay, looks like everybody's doing good. I'm on. Okay, so once you get to the REPL website, click on the code, type in Python. All right, I'm getting thumbs up. Awesome. All right. Okay. Now that we're all here, math, right? Some of you already know a little bit about Python, you guys said. So you know when you want Python to print out something, the cool thing about Python is you talk to Python just like you talk to anybody, like how I'm talking to you right now. That's almost exactly how you will speak to Python. So you type in print and then put in parentheses like this. And you can put any math operation in here, 2 plus 2, right? So we all know what 2 plus 2 will be. We'll run the code, and 4 comes up, right? So so we can do math in Python, and we can do any operation. It doesn't have to be just addition. Oh, math and numbers. So math and numbers are, like I said, they're exactly the same. But what if we wanted to use a big number? Like I showed you before, those the code that I wrote had really, really big numbers in it, right? Like numbers in the thousandths place. So when we write a number in the thousandths, like 3,000, that's how we would write it, like on a piece of paper or on a test or something. We would separate the 3 from the zeros with a comma. That's how you write 3,000. Well, in Python, if you do that, it means something else. I'm going to show you. So if we want to know what 3,000 plus 2 is, we know the answer would be 3,002. So let's run this code and see what happens. See, it comes up with 3, and then it has a space, and then it has a 2. Well, let me show you what Python is thinking when it sees that comma. One second. I don't know why this, okay, there it goes. Okay. Oh no, did I exit out? I think I exited out. Okay, well, I'll go back to it. But when Python sees the 3 in here, you have 3,000, and we wanted to add it to 2. 3,000 plus 2. Well, it saw this 3, right? And then it saw this comma, and then it saw the zeros. So when it sees this comma, it separates 3 from the zeros. So it printed out 3 like we wanted, or like we told it to print out 3, and then it saw this comma, zeros, and then the 2. So what it saw was it wanted these 3 zeros, and it wanted to add it to that 2. So that's why we got what looked like 3, 2. And that's but what we wanted was 3,002, not 3, 2. Hold on one second. I have to redo my REPL. I accidentally logged out. Okay. So if we wanted to know the answer to that question, we just leave out the comma, 3,000 plus 2, and then we run the code, and it should be 3,002. That's what we would expect. Now, we can use commas for things in Python, okay? If we wanted to know what 3,002 was, but we also wanted to know what another operation was, like 3 plus 5, we can separate it in the same line here, 3,000 plus 2, and then we have this comma, and then we want to know what 3 plus 5 is as well. We run this code, and it gives us a space, and then it tells us the answer to the operation, right? So that's what we can use commas for. Just don't use the commas to separate the numbers, or to separate one number, but you can use it to separate, different operations if you want. Okay, and we can do every operation. So far, we've only done addition. We can use Python for subtraction. So we want to know 30 minus 6. We can run that code, and it tells us the answer. We can also do division. It's just the / where the question mark is. You just shift, or not shift, but where the question mark is, that's the / that you want to use. So 4 divided by 4, we should get an answer of 1. So when we use division signs, Python will output the output with an answer with a decimal. It will always put a decimal for that. So decimals are fine. You can use decimals in your code. like, 4.5, and we wanted to add that to 6, that's fine. You can use decimals and you can run that and it will give you your answer of 10.5. But what you cannot use, like I harped on pretty hard, was the commas. You just cannot use commas to separate numbers. Like you couldn't do 4,500, Now we can also do multiplication. So if we wanted to do multiplication, 6 times 7, you use the asterisk. The asterisk shows multiplication. The asterisk is Shift 8, and that's how you would use this for multiplication. 42. That's what we would expect. Okay. Now, what about who remembers this? Does anybody know what this means? PEMDAS. Right?
Pemdas.
PEMDAS. Very good. So it's the order of operations, right? Parentheses, exponents, multiplication, division, addition, and subtraction. Awesome. You guys are really smart. Python does this for us. So we don't have to worry about doing anything special to our code. Python will perform this action for us. So we can do an example here, put in a bunch of random numbers with a bunch of random operations. 6 times 7 plus 4 minus 5, and we can run this. It'll be 41, right? So it'll perform the operation for us. With this, we don't have any parentheses in it. Let me go back to the Jamboard here. If we want parentheses, we started off with our print, and then we always have these parentheses associated with print. Anytime we type in print, we put our things in, we put the operation in parentheses, right? So these will always be there. They're always here. And then if we have our operation that we want in here, like 5 plus 4 plus 3 minus 2, if we wanted, like the question that our textbook is asking us makes us do these first, they put these in parentheses, that's okay. You can put parentheses inside of your other parentheses, okay? So I know it'll look kind of funny because you have 2 parentheses right here, right next to each other, but that's okay. Python will know that these 2 outside parentheses are together and these 2 on the inside are together as well, right? So you can do that. And we can go back and see how that looks. Like on this one, I'll add a few things, times 9. So on the outside here, I can put more parentheses in. And even though there's 2 parentheses right next to each other and it looks kind of funny, you can still run that code and it'll still come out with an answer. And it just so happens to be 1. Okay. Let's see. Next, let's talk about exponents. So we talked about a bunch of the math so far. This is really kind of the last thing about the math. Exponents, we know like 2, we want to do 2 squared. So 2 raised to the 2, we know that means 2 times 2, right? So this, with a 2 raised to a little 2, we know that means 2 times 2. Well, we don't really have a button on our keyboard that has a little 2. How do we tell Python that we want to raise a number to another number? Well, there is a way we can do it. You're not going to, when you have Python, like if you had 2 raised to the 15th power, or you're not going to write 2 times 2 times 2, like all the way to 15, right? Like that's way too many 2s. You don't want to type all those 2s. So all you have to do is you put your 2 and then you put 2 asterisks, the multiplication thing, the shift 8, and then you put the number. So that is the same thing right here, is the same thing as this. And I'll show you that next. We can erase this. So we start off with our print always, and then we have our parentheses. And we wanted to know what 2 raised to the 15th power is. So two exclamation points, or I mean not exclamation points, but asterisks, 15. And that will give us our answer, huge answer, 32,768. So that's just 2 times 2, 15 times. And that's how you would use exponents. Now there's also what they're called Boolean statements. And it's a funny word, but they're greater than or less than statements. Python can do those too. And Python will tell us if this is true or false. Here's what I mean. So we have 6, and we want to know, is 6 greater than 4? Let's run that. And Python tells us, yes, it is true, right? We can use, and if it's not true, what will it say? Let's see what it says. So is 6 bigger than 9? I can run that. No, it's false, right? And there's also other symbols, right? So they're just like the symbols that you're already familiar with. We can do another one. Let's see, is 5, and I'm going to throw another symbol at you. Exclamation point equal means not equal. So I'm asking Python, is this number not equal to this number? So is 5 not equal to 7? True. The answer is true. Now, if I did put a 5 here, it's going to tell me that that's false. Why? Because 5 is equal to 5, so it can't not be equal to 5, right? And I'm showing you guys this symbol because it's going to go into the game that we're going to make. All of these things that I'm teaching you will go into the game. And it's just a matter of putting all of these things together in a way that Python will recognize it and do the things that we want it to do. There's some more symbols. I'm going to show you. I'm going to stop sharing for a second and see if there's any comments. Oh, sorry, I haven't been reading your comments. So I'm going to look at them, make sure nobody has any questions. Python is smart. And the game that we're going to be making is called the number game, or guess the number game. I'll explain more when we get to that point, but I'm just teaching you guys the basics right now so that you can make the game, that you'll understand how it's working. Okay. Now let's go back. So we showed, how does everybody feel about the numbers and math so far? Pretty good. Pretty easy stuff. It's just like everything else that you know. It's really intuitive. That's why I like Python. There's not much else you have to learn. Just a few little rules that you have to learn to be able to speak to Python. Let's see. Everyone feels good, easy. Yep, it's all super easy stuff. Python's really cool because you can, these really basic operations that we're learning, you can plug in huge numbers, huge calculations, just like what I showed you with the solar system. Those are huge numbers, and Python just does those operations for us. Sorry, yeah, I don't know, how do you access the chat while you're sharing. Yeah, I don't know.
Oh wait, there's a more button at the top. You should see a bar at the top, right?
Yeah, I got the more. So, oh, I see the chat. Here it is. Okay, cool. Thanks, guys. What is the code that lets you drag the blocks? That's called block. I think it's literally just called blocks. I'm pretty sure it's it's similar to Python, but that's why I like Python too, because Python translates a lot to other languages. So I'm teaching you guys like the basics of Python because you can take it and you can transfer it to other skills, other languages. When you go and actually start looking for jobs and stuff with Python, eventually in the future, it looks really good because Python allows you to transfer over to whatever the company is using. A lot of times they'll be using Python, but Python's very transferable. Okay, that's everything with math. We went over the differences between math in the real world and math in Python. There's very few. You just have to type in print beforehand, so Python will spit out the output. There's no commas in the numbers. You only use commas to separate operations. And yeah, that's really the only differences. Math is pretty easy with Python. Now we went over math. Now what about words? How can we make Python print out words?
I know.
Oh yeah, how do you do it?
Using strings.
Exactly, they're called strings. So what's the first thing you need to do once you type print?
Quotes.
Very good.
Single quotes. It doesn't matter.
Exactly. Yeah, exactly. You can use single quotes. I like to use single quotes because you don't have to type, you don't have to hit shift. So put quotes in, type whatever you want.
Hello encyclopedia.
Hello encyclopedia. Encyclopedia is a little too big for me. Okay, and you can run that, right? And then it prints out exactly what's inside those quotes. I have a question for you. So we've been using math, right? What if I put 2 plus 2 inside of the quotes? What's going to happen then?
Error. It's going to give you any. Oh, wait. It's going to print 2 plus 2. It won't do the operation.
Exactly. Yep. So that's something you have to remember sometimes. If you put anything that you put inside of quotes, inside of double quotes, it will print out exactly what you put in there. What's up? Seamus, you have a question, bud? One. Print Orion.
Orin. It prints Orin.
It's okay. Sorry. Okay.
Orin is 9 plus 1 each, and that if you plug in that into the Python code, it'll say Orin is 10. Actually, wait. It says print Orin is comma.
Yeah, you have to put the comma.
Because then.
Yeah, what would happen if I don't put the comma? I run it. Syntax error.
Let's do it trial and error.
Oh, he just did it, buddy. Yeah.
Yep. See, that's what happens with no comma, right? It doesn't recognize. It thinks I'm trying to put these two things together. So if you put the comma, and then that means we put a separation in there. Ryan is 9 plus 1. Awesome.
Add with strings, right?
You can add strings. Yeah, you can add strings together or multiply them. So if I wanted to say Orin, oops. I wanted this string and I wanted to multiply it by 3. Just gonna say his name. Orin is. Yep.
It's hilarious.
Yeah, it is. So you guys know strings pretty good. we know that we can, we have to put quotes, right? You can't use one and the other like this. It's gonna give us an error. And the cool thing, another cool thing about Python is when you do make an error, it tells you the line number and it shows you where the error is occurring. So you can go directly to that line of your code. If you have like a really long code, go right to that line of code and you usually find out what you did wrong pretty fast. Does anybody know, Oren, do you know how to make a line break? So like if I had a long string here, hello everyone, my name is Cody and I am here to teach you about stuff and things. I got this really long string, right? When I run the code, it just prints it all out until it gets to the end, and then it goes to the next line. What if I wanted to break it up into different lines? Do you know how to do that?
Mhm.
How do you do it?
You do it by backslash.
Yeah, I think you had it.
This comments down here.
Yep, right. That's a forward slash with an N, exactly.
Backslash. All right.
Yep.
Yeah.
So yeah, you're right. Backslash N.
It stands for slash new.
Very good. What's up?
You know, but if this was an iPad and we were writing down out of memo in Python,
Yeah.
then backslash n would equal enter.
Very good. Yep.
Enter,
Awesome.
enter, return,
Yep.
or return.
Yeah. Awesome. Very good. Very smart.
Basically, like, so like, doot, doot, doot.
Mm-hmm.
So instead of going like this,
Yep.
it'll just go boop,
Yep. Right.
so on and
So-
so on.
So let's see what it looks like here. So we
Yeah.
put the backslash N or enter. Now let's run it. I put it in between everyone and then my name is. See, yep. It breaks up into a line. And the thing to remember about this, sometimes I mess up, is I put the backslash N outside of the quotation marks. So if you put it outside of the quotation marks, you will return with an error. So remember to keep them inside the quotes. If you usually make that mistake when you want the break to be at the end, which in our game we'll be putting breaks in at the end of our sentences. So if you want to break at the end, it has to be inside the quotes. All right.
Oh, that'd be cool.
What's up?
I just thought, what if we could, like, code?
Mm-hmm.
What if we could code our? What if we could, like, send our code to other people in
Yeah.
like pictures and stuff, and then someone plugs that into Python, and then you did a manual decryption of that, things will get pretty cool.
Yeah, you can get pretty cool with Python and coding. Yeah, it sounds like you're gonna have a pretty good career in coding.
Actually, career dream is actually engineer at NASA.
Oh, cool. Very cool. Okay. Now let's move on to something else that we're going to be using in the game.
Oops.
Yep. Well, not yet. Not loops yet. We're going to talk about input and variables.
Oh, I know input and variable.
Very good. Okay, what do you use inputs for?
Oh, like user input. Like let's say, you want to like make a program that prints out your name. So if you want to do it, like Python says, what is your name? And then you type in your
Yep.
name and print it out.
Right. So input, we wanted, yeah, you said what is your name?
Yep.
So what should happen here? It asks us our name, right? Cody.
I like to put a few spaces at the end, so like it's
Okay. What else? But what else that we like just talked about can I do? Because
slash
it looks crazy, right? A name, Cody. You could put.
We
if you
can
said-
we
you
could
put-
print prompts out.
Yeah, but like if you just \n, oops, not next. Control Enter. It'll just break the line, and it looks a lot cleaner.
Yeah, but you could actually make the input, like you could assign it a variable. So you could actually make it print out your name, like print G or whatever you want to name the variable.
Yeah, you mean kind of like this?
Yeah, like name the variable whatever. And then
Yeah.
you can print.
Yep, that's what I was gonna get at. That's why I grouped input and variables together. So, so what is the input now, and which one is what's the variable?
The input is like the string, and then the variable is the name.
Exactly. Yeah. So anywhere now that I type name in my code, like doesn't matter if it's on line 100, you know, it knows that my name is whatever has been in here. You know, I don't have to type in what they put, right? So what happens if I type print and then I put name here with no string?
That it'll print.
It'll print what?
It'll print your name.
Okay, yeah. So I haven't told it, or it'll print whatever I type here, right?
Yep. Well, why don't you do your name is plus equals the name? It'll do your name is Cody.
What'd you say?
Type in a print statement, and then all you have to do is do in strings do my name is, and then close the strings, and then do Cody.
Oh yeah. Okay,
Name.
I see what you're saying. Yeah, it's the same deal. Okay, so you guys seem like you're
We
pretty
figure
well.
out a way to get the computer to talk to us and make the code ask us questions.
Yeah, we can do that too.
So you wanna know what? So it's down here in the comments. This is what we just did. So what we did is it's
No, I see. Yeah, print. You said name input. Yeah, what is your name?
what is your name?
And then you can say
And then,
yeah.
and then after that you have to go into the code block and type in the answer.
Yep. So we want it to tell us hi, right?
Wait,
And
we
then
need a break between the two.
yeah, exactly. So the break with the comma, right?
And then do name.
And then name, and then what?
Well, we need to have a break. We need to have 3 lines for this. So like, what's your name? Oren. Hi, Oren. Or something.
Right. Very good. So this should work, right?
What is your name?
Well, this is just an idea. Yeah. See? And then
Yep.
like, if you had put in a ton of stuff in it,
Mm-hmm.
then it would be like, then it could be kind of like then it could be kind of like a series of questions like, what's
Yeah.
your name? Oren. Hi, Oren.
Yeah, exactly. So it's
What's your-
like when you play video games and you're playing the
Oh,
story. Exactly,
Yeah.
you're playing the story. That's what the coders did. They wrote code just like this, and when you play the game, the computer character asks you your name, and then after you do that, the computer always remembers your name. And that's exactly like you're already
Yeah,
on
it's
it.
kind of like, it's kind of like an intro. It's kind of like the beginning of a chat.
Exactly.
What's your name?
They set your name to a variable.
What?
They set your name to a variable. Let's say
That's what we just did.
Name 1 or something. Name 1, name 2, name 3 or something.
Yep. That's exactly what we did. We can have
Like-
100 different variables with 100 different
Yeah.
names.
now that you think about it, it's kind of creepy when they store your name.
I know, right? They store
It would
everything.
be
on the
even
internet.
creepier if we had programmed it to not just print, but to speak.
Mm.
That would be super creepy.
You
Yeah.
can do that by installing some kind of module.
Then
But-
it would be, yeah.
But I mean, I've tried that. It doesn't work for me.
Yeah. Well, so like I said, keep practicing. You guys are gonna be so much better at this than me. Okay, so we talked about variables and inputs. So you guys have a really good handle on that. What's up, Seamus? Or Oren?
Yeah. So like, what if for the module idea? What if we had just tricked the computer to think print is speak, and we don't have any screen, but we do have a speaker, and we rewire the print into the speaker there. Then
You should try it. You should
and
try it.
then we could
You have to
also
find
have a
the library
microphone.
for that.
Yeah,
That's
but then things will get really interesting.
Yeah.
That's
Yeah.
actually more complicated than it sounds.
I know
A
because
lot of things in
then-
Python do. They
because
seem
since
complicated.
There's no screen. Then you have since there's no screen, then you have to have a microphone, and then
Mhm.
yeah, and so on and so on.
Are we gonna learn about the turtle?
No, we're not doing turtle here. We're gonna make the game here soon. Though.
Okay.
I
We're
mean,
doing
'cause
the game now or what?
I'm doing it on normal Python. I'm not doing it on.
Yeah, we're just on normal Python right now. Let's go over loops quickly. Maybe not everybody knows about loops, so we're gonna go over loops, and I'm gonna explain what they are, even though you probably already know. A lot of you know what they are.
Wait,
What's up?
while loops, for loops, or
We're gonna use while loops and if and else statements.
okay, no for loops.
Yeah, we're just using while. While that's what I use the most, especially with physics. I use while loops.
Like, as long as this factor is in play, do this. If this
Exactly.
factor is not in play,
Yep.
You're
So
done.
while you have, some condition.
Wait, do you know how to make comments?
Yeah. Okay.
Yeah.
That's something I was gonna say. Some of you guys can, if you wanted to, you can
Yeah.
put a hashtag there. But I'm gonna explain what loops are really quick, or what a while loop is very quickly. So while there is some condition, I'm gonna draw it out. So let's see, while, we're gonna say while time, we're gonna use time as a condition. Time is less than 3 seconds, right? And we have this turtle or whatever that's running in a circle. And we have this turtle that's running in a circle, and we say, we want you to run in a circle while time is less than 3. So when time is at 1, of course, it's still running in a circle, right? It's still in that loop. And then time goes to 2 seconds, still running in that loop. And then once time hits 3, this is no longer true. It becomes false. And then the loop breaks and it goes to the next line of code.
basically a loop until.
Exactly.
And I created a program with the while loop.
Mhm.
That's pretty funny. I mean, it can get funny.
Yeah.
I'm gonna post it in the chat right now.
All right, cool.
Print, I am typing while true G input say something, print G.
Right.
Or roughly.
Okay, let us this is the basis of the game. We have to understand the while loop for the game. So the best way to understand it is just literally to type it. So let's make this game. And I'm going to explain each line of code while we type it out.
Wait, is it a number guessing game?
Yeah, have you already done this?
Yes, I've made like 3.
Okay, well, let's make another one. So what's input, or do you know how to import?
Yep.
Okay, so what import is,
Random.
yeah, you can import random. So we're importing random.
It doesn't want to copy that.
Import, you're taking like a system that Python already knows. There's like thousands of them that Python already knows, and you can just import them right into your code.
Yeah.
So what import is doing is adding extra functions.
Oh wait, there's one that's actually called date time.
Yeah, that's one.
Yeah, and like it can tell you the current date and current time.
Yeah, exactly. So there's thousands of them, and like I couldn't tell you all of them because there's way too many. But the more you code, you come across more, and then you kind of remember some of them. But if you're writing a specific code, you can even Google like what something to import. Yes, you have a question?
So basically using massive amounts of complex Python and a few clockwork links and commands and if then commands, you could practically make a supercomputer that tells you things.
Exactly. Yeah, I don't think my
we could say, "What is my name?" and it could do like vocal recognition or something.
Yeah.
Oh, okay. I actually tried that. I tried to make a desktop assistant with only if else loops, and I like gave up on it in like the next hour because it would take ages. So I decided I would follow a tutorial on YouTube on how to do AI.
So basically, you were trying to create your own Jarvis.
Exactly, and it didn't work.
What? Jarvis is pretty much that type of computer.
I mean, you could make him with if loops if you like had a bunch of time.
All right, let's keep going on the game. So
I tried doing that before with a robot.
Now we're gonna make a variable. So we want the number that the computer is gonna randomly think of to be a part of this random bank that we already imported. And then when you put a period, you're describing the thing before it. So it's going to be in a range. It's called rand range. And then in parentheses, we want it to be 1 through 50. So we just created, so the number, when the code runs, it's going to think of a random number, but it's going to be in the range of 1 and 50.
Wait, doesn't that mean it's going to be in the range of between 1 through 49, since Python starts counting at 0?
2 through 49.
Yeah. No, yeah, it could be. Yeah, you're right.
If you really think,
Lauren, chill out.
it could be.
Look, please.
Sorry, it could be 1 through 9, or it could be 2 through 9.
Yeah, it could be. But we'll just keep it simple. And now
it could start as 2 or 1. So yeah.
Yeah. So don't guess 1 or 50. Let's start.
Yeah.
So your guess, we want it to be an integer. So we're going to type int parentheses, and then this is where our input comes in. We want the input we want to tell them to guess the number, right? Whoever's going to play our game. So hey, guess. That has to be a string, right?
Yep.
Guess a number between 1 and 50. Or I guess we won't tell them to guess 2 through 49. We'll try to trick them. And then here we're going to do the \n. So when they can type their guess underneath the number or underneath the string. So far we've imported a random numbers list. We narrowed it down 2 through 49, and then we made an input their guess, and it has to be a number. That's where this int comes in. Okay.
Let's give it a game.
Hold on. No. Is
Now,
that while loop gonna happen?
Yeah.
now that we make a while loop,
Yeah. Everybody ready to make the while loop? All right. What's the first thing I do? While.
yes, and
Okay.
then
Guess something.
guess is not equal to number.
Yeah. Very good. Not equal to the number. All right.
And then
Don't forget the colon. Yeah, make sure you have the colon, and then if this automatically does it for us, but make sure it's tabbed underneath the while.
there's actually a mistake here.
What's up?
Okay, so when you make the variable guess, it should be in the while loop because it's only going to ask you to guess once.
That's good. But before the while loop starts, I want them. I need it there. Right.
To make
So
it,
you're onto something, but we're about to get to it. Okay. Now we need an if statement. Any ideas? We're gonna say if what? It's one of our variables.
if guess
Okay.
is greater than
Yeah, I like that.
number.
Yep, greater than the
Wait,
number.
how about not equal to?
We said that's what our while loop is, right?
Well, if it's not equal to, then won't it always be printing like whatever you want it to print? Like
Well,
if
you'd have to choose the. Well,
One.
sorry.
So inside the while loop, if their guess is greater than the number that the computer's thinking of, then what?
then it needs to print too high.
Yes, exactly. Oops.
And then add an well, don't we need elif?
Not yet,
If then else.
because they haven't guessed yet.
Am I correct that it's if then else?
Hold on.
And basically what that block says is if this factor is true, do this. If not,
Yep.
do this other thing.
Okay, so earlier you said we need our input inside the while loop, right?
Yep.
Yeah.
So let's just copy and paste this into
What?
our while loop.
I have couldn't we do this like at the beginning set guess to 0?
Guess.
Don't we- Yeah, just name it, just give it a random.
Yeah, you could. I like putting words with it just because it helps me remember if you're writing a big code, you know.
Yeah.
Yeah, so you can put anything. You can put it X, Y, Z. It doesn't matter as long as you remember it. It's fine. But I like to assign it a tangible like word almost.
It doesn't work.
I have a typo.
Oh.
Okay. So now we need an else. So we created the loop for if they guess the number too high. What if it's less? The only other option is they guess a number that's too low, right?
Yep.
So now else.
But if you actually want to print the you got it or like the you win thing, won't you need an else if?
Yeah, you guys are always thinking ahead. This is our if. If we have our if and then we have our else. So now we need to define the else.
Else
So
too low.
exactly. So else, I guess a big number. And then we tell them try again, and then now we need that we need that input again, right?
Yep.
All right, so just paste that in there.
I might have a more quicker way of doing that.
You probably, I mean, there are always 100 ways to write a code. So this is like, I thought this was gonna be more for beginners, but you guys are like, you got this pretty good. Okay, so now we've defined the parameters of our game. We have the while loop. So while their guess is not equal to the random number, we have the statement for if they guess a number too high, and then we have everything else, which the only other option is too low of a guess. And we have our inputs in, so now the game's over, right? That loop will continue and continue until the guess right here does not equal equals the number. So as soon as the guess equals number, loop breaks, game is over. So now we need to have Python print like something like they won, right? You got it? So has anybody seen any mistakes with the code? Any questions with the code? Any questions in the comments?
What you could do at the end is print how many tries it took you to actually guess the number.
You could. There probably could. I don't know how, off the top of my head, how I would do that, but there's definitely a way you could.
I know how to do that.
Yeah, how? Show me how, or tell me how.
I mean, like the way I did it, like the way I make my number guessing games, is that I put my guess, like the input, right at the beginning of the while loop, so it's gonna keep on repeating it.
Mm-hmm.
And I don't have to duplicate it every time. And then after that, I have a variable named tries, and then I always do and then I always set it to tries equals to tries plus 1.
Mm-hmm.
And then so at the end, I print number of tries it took you in strings, and then comma, and then tries.
Yep, that's good. But for now, we're just making a game. Yeah, you can add more things to it once you. So not everybody is well versed in Python. So this is just for beginners. Let's run this and see if we made any mistakes, if there's any errors.
Oh, and a tip for testing it is to actually like print the number at first to see if you could like instead of having to like play it over and over again.
Yeah, you could just say print number.
First, like print the number so it's a lot easier. That's what I like to do.
Okay, so in the chat, somebody give me a number to guess.
13.
I got 30 here. I'm gonna guess 30. All right, that was too high. Guess a smaller number. 24.
Maybe 13.
Guess a smaller number. I got a 5. Guess a bigger number than 5 in the chat. 9. Guess a smaller number than 9.
4. No, not 4.
8.
6.
Smaller.
Try 6. It's
Smaller.
7 or 8.
7. 6. Oh, we got it. All right. So our game works. All right, let's go over this code for everybody. So the very first line here is something I didn't go over in the beginning of our talk. Import anything that's highlighted in blue. Python knows what that means. Like it already pre-recognizes those words. So like all of these highlighted words here, input, this integer.
Lowercase p. That's why it was punishable.
It knows those. It knows those words.
We've been stuck on an issue for a long time, and we finally got it.
Can I show you how I actually made my number guessing game?
Sure. How are you gonna show me?
Can I share the screen?
No, I don't think you can share a screen with everybody.
Oh, dang it.
I'll post yeah, there's more than one way to skin a cat for sure. You can. There are other ways to make like this game. This is how I like to make it. It's really simple and straightforward. All you have to do is assign 2 variables. So we went over what variables are in Python.
We can make a guessing algorithm to figure it out.
Mm-hmm.
So variable, anytime a variable is just assigning a word with any meaning, right? So anytime I type number now into my code, it highlights here. It knows that that word means this random range of numbers. Okay. Same thing with guess. Guess is a variable. Now, anytime I type guess into my code, it knows that guess is going to equal, with this equal sign, it's going to equal whatever the user inputs in here. And that's what an input is. Anytime you write an input, you're asking the user for an input. So you're usually asking them a question, and whatever they answer, that is their input, right? So in this case, our input was guess the number, and whatever number was their input.
This was fun.
Cool. And then we went over while loops, what while loops are. While loops are that explanation I went like with the rabbit chasing its tail around in a circle. It's going to keep doing that until whatever we put here in the statement becomes not true. So like in this case, it was as long as the guess did not equal the number, the while loop was going to continue and continue and continue, right? And then once they guessed the number, the while loop was no longer true because the guess equaled the number. And then after the while loop is broken, it goes to the next line of code, which in our case was 13. And the next line of code was to print a string. And remember, the string is just anything inside of quotation marks. It's words inside of quotation marks, right? And then we went over the if and else go inside of our loops. Those are the parameters of our loop. If the guess, in our case, the guess was bigger than the number, then this happens. That's what if is. It's if this is true, then this happens. And then if anything else was the case, then this happens. That's what the if and else statements are. Does anybody have any questions over anything that we went over with from the math to the strings, variables, and loops, or anything inside the number game? You can tell me in the comments, and I'll try to answer your questions. Any questions? No questions?
I just got one cool idea.
Okay.
Remember that planet algorithm you had?
The planet?
The planet one?
Planet. Yeah.
What if you had slowed it down to real time? What if you had slowed down every dot to real time, and then you could like send it to NASA for like, here's when we should launch this, and here's when we should launch that.
Yeah, I'd love to. But I think they're using a little more advanced.
But it does work.
It does. Like I could absolutely calculate the exact time we should launch.
How did you get the sun to look so shiny?
That's just how VPython is. If you guys want to try VPython, I don't know if you've ever heard of Trinket. I'll try.
Did you do that with the turtle?
They have turtle here on Trinket.
No, I mean, like, could you do it, like, I'm using idle right now.
I don't know. But something you have to try out. I only really know Python and VPython. That's what I use the most.
I mean, I'm using, like, the Python that you have to download.
Oh, okay. Yeah, you should be able to do it there. I don't know about this. Like, I don't know about VPython. VPython, the only source I know that uses VPython is Trinket.
Oh. Well, I mean, I really don't care about how the graphics look as long as I have a working solar system model thing.
Right. Yeah, these graphics aren't that great, but yeah, it works for you. So, yeah, so like for an example, we're talking about the math. That's what I mainly use Python for math because these calculations are so big. The main line of code in this was this line right here. So it's the force of gravity is what makes all the planets rotate around each other, right? So it's the gravitational constant multiplied by the masses of whatever objects that you're calculating. Most for our solar system, I just use the sun to each planet, right? So those are huge, huge numbers, the mass of the Earth and the mass of the sun. And then you divide that by the distance between them squared. So those are huge numbers, and that's just an example of math in Python that I don't even have to know what the answer is, and it still works. And then I can still get the results that I want. I can still get the rotation of Earth. If you sat here and watched it, it would rotate 365 times before Mars went around twice, or went around half that. So it actually works out perfectly fine without even knowing the answer to these questions or knowing the answer to these calculations.
I have never heard of all of that math that you just talked about.
Yeah, that's advanced. It's Newton's, gravitational law. So don't worry about that. You don't have to know. That's a cool thing too. You don't even have to know these formulas. You can Google them, and then if you know how to code Python, you can go in and code it, and you can do the same math that physicists are doing right now, in Python. You can just code it, and that's what a lot of physicists are doing now. We have to be really good at Python because these calculations are way too big and they're way too complicated.
That's just, I don't even know how Python handles that.
I know, it's crazy. It's pretty cool. That's why Python's so cool, and it's fun. It's really fun to learn. And you can do a bunch of other things like I'll show you some of these projects that I tried. Oh, actually, you can see the sun is actually moving a little bit because of the gravity of the other planets. That's really zoomed in. We'll look at some other ones. If you guys ever want to try this, you just go to trinket.io, and you have to make an account. The cool thing about REPL that we're on right now is you don't have to make an account or anything, but here just make a free account, and you can do VPython. It has a bunch of other languages as well. But here you can, I like this because of VPython. And you can take the same tools that we learned that I taught you here today, and you can just plug them right in here to VPython, and it'll work. The only difference is you have to make the shapes. And that's what these first lines are here. So I made the rocket and I made the Earth. And there it goes. Oops. And this was like an example of a rocket, what it would take to get it off of planet Earth. I didn't code all the crazy math in here, but you see the point. I could make this actual size, I can make the rocket actual size, and we could launch it into space with VPython.
That's just cool.
Yeah, it's pretty cool, right? So you guys definitely check it out. There's resources out there to help teach you this as well. But it's like I said at the very beginning of this course, the things that I taught you are the things that you're going to use every single time that you code Python. You might pick up some extra tools here and there, but those basic ideas are the things that you're going to be using every single time you code. Especially whatever you decide to do in the future. If you decide to go into a science field, you'll be using a lot more math. That's why I like to lead off with that, because that's where I am. I use it more for maths.
But for some reason, I like to code, but I don't like math.
Yeah, well, I mean, math's not for everybody, right?
I hate math.
Yeah, it's all right.
It's
Uh, but that's cool about Python. You don't have to really be that great at math. You just got to understand it, you know. You don't have to be that good at it.
You have to do it
That's
like you don't have to get the right answer, but you know what like it's gonna do.
Exactly. And you can even just Google a formula, put it into your Python code, and then plug in whatever numbers you need, and it'll just pop it out for you.
But if you ever go to like a Python interview and you actually need to answer the question, which would never happen, but
Yeah. Well, as long as if you go to a Python interview and you show that you can get the answer through Python, you got the job.
yeah.
All right.
Yeah.
Minecraft coding is like coding but with JavaScript. Yep. I had a teacher that used Minecraft coding to show us some stuff.
I actually had my a friend he taught me how to actually like hack sort of
Yeah.
Minecraft with Python.
Wow.
I mean, I don't know how he did that, but he actually made sheep fall from the sky 24/7.
Nice. Okay, everybody. That's really all I had to teach you. If you guys don't have any questions about any